Hello and welcome to Algebra 1, Chapter 7.3, and today we will be discussing polynomials. So what is a polynomial? A polynomial is either a monomial or a sum of monomials. And so by prefix poly we mean many, and nomials would be terms, so many terms. So you can have a monomial, which is just going to have one term, or you can have a binomial that's going to have two terms, or a trinomial that's going to have three terms. And terms are separated by addition and subtraction. So just as an example here, a polynomial could be, a monomial, 4x, there's just one term. But a binomial might be 4x plus 3y, and then a trinomial would be 4x plus 3y plus 2z. So you're adding and subtracting signs separate terms, and however many terms you have is what type of polynomial it is. Anything more than 3 terms, we just call a polynomial. So here we have an example that we want to state whether each expression is a polynomial, and then if it is, we want to identify it as a monomial, binomial, or trinomial. So to start out, we have 6 minus y, and these are both terms, so this works. These are both monomials, and so there's 2 of them. So yes, this is, and it is a binomial. Okay. Looking at the next one, how many terms do we have? We have 3 terms. Yes, this is, it is a trinomial. Now looking at the last one here, and we have a d to the 4th on the bottom. And so can we have a polynomial with a variable on the bottom? No, we can't. And that really goes back to one of the earlier lessons in this chapter about you can't divide by a variable. So no. And then if you wanted to write an explanation, we could say because dividing by a variable. Okay. So the next thing we're going to do, and this you find these problems a lot in algebra, is what's the area of the shaded region. So if you were going to say what's the area just of this region. And the best way to do this is to actually find the area of the entire thing, because you could make these 2 smaller regions. You would have 2 trapezoids. You could find the area of that. Granted, we don't know enough information, but you could. But you could find the area of the 2 smaller regions and add them together. But a much easier way is find the area of the entire thing and find the area of the parts you don't want and subtract them. Because the area of the whole thing is a triangle, so let's call it the area, we're going to call it the big, this is the whole thing, and it's a triangle, so we're looking at length times width. Well, its length looks to be b, and its width is this, which is actually 2h, because we're going to add those h's together. We have this h up here plus this h down here. So we're going to get a big area of 2BH. And then if we do the area, we're going to just call it the area of the little region. This is this triangle down here. So you could also call it the area of the triangle. So remember what your formula is for area of a triangle. 1/2 base times height. And if we look, probably shouldn't have done that second equal sign. They used b for base, they used h for height. So there we go. It is just 1/2 bh. There's nothing to plug in there because they did not change the symbols. So if I want the area of the shaded region, I'm going to take the area of the big region minus the area of the small region or little region. I guess I used little in this case. So that is going to be 2bh minus 1/2 bh, which would leave us with 1/2 bh, or you could write it as 3/2 bh. That is the area of the shaded region. The next thing we're going to talk about are degrees of monomials and polynomials. So starting out with a degree of monomials, and make sure this is just for monomials this time around. So monomial, one term, it is the sum of the exponents on the variables. Okay, the sum of the exponents on the variables. So if we look over at this table here, 8y to the fourth, so the exponent on the variable is 4, so it's degree 4. 3a has a degree of 1 because any variable without an exponent has a degree of 1. Now this next one, we're going to have to really use this. It's the sum part. So we have x to the first, y to the second, z to the third. Add those up. This has a degree of 6. And our last one here, 7, is going to have a degree of 0 because you could put an x to the 0 on it and it would still be 7 because remember anything to the 0 power is 1, and so then its exponents would be 0. So the degree of a monomial, you're going to add up the exponents. The degree of a polynomial, so now we're into a polynomial, you do a little differently. You take the greatest degree of any single monomial. Okay, so the greatest degree of any term, those are your monomials. Make sure you get that written down. We're going to look at some examples. Okay, so this first example here has how many terms, first of all? We have 4 terms. And so to find the degree of the entire polynomial, you're going to look at the individual degrees of these monomials. So 12 has a degree of 0. 5b has a degree of 1. 6bc has a degree of 2 because you're going to add, both those have 1s there. And 8bc squared has a degree of 3. You're not adding those together. You're going to take the biggest number no matter where it is, and that's the degree of the entire polynomial. Okay. So we're going to do it 2 more times here. So a degree of the individual term, so that has a degree of 2, that has a degree of 1, that has a degree of 0, and you're taking the biggest number, and that's the degree for the entire polynomial. Now this last one is just a monomial, just one term, so you are going to add those. And it would have a degree of 8, because 2 plus 5 plus 1, don't ever forget that 1, we had a degree of 8. Alright, the last thing we're going to talk about today is writing polynomials in order. You can write them in ascending order or descending order, and that is in terms of their powers. Okay, so if I just randomly made up, let's see here. Alright, so we're going to have this trinomial. So ascending order is smallest to biggest. So in terms of their powers, 6x squared is the smallest power, then x cubed, and 7x to the fifth. So their powers or their exponents get bigger. Descending order, and by the way, you might make a little comment by this descending order. Descending order is how you write things. Unless otherwise noted, they need to be in descending order. So descending order, we're going to start with the highest power and then work our way to the lowest power. Alright, so we're going to try an example here. So we are going to arrange these terms so that they are in ascending order. So it's telling us ascending order, so smallest to largest. So what here has the smallest power would be 16, and then so because that has a power of 0, and then what 2x has a power of 1. Okay, now power of 2, you got to take the sign with it. So we're going to do minus x squared and then plus 14x cubed. So our exponents are in ascending order, 0, 1, 2, 3. Alright, so the last one here, smallest exponent. Okay, and now you probably notice, well, what do I do? There's x's and y's. Let's go back up to our directions real quick. And it says so that the powers of x, so it's specifically telling us. So what here has the smallest power of x? It is this 7y squared. It has a power of x that's 0. What has the next smallest power of x? 2xy cubed has a power of 1 for the x's. And then next, we have a power of 2 for the x's. And then finally, a power of 3. All right, that's what we're going to do on the lesson today. We will finish the rest of your notes in class next time. Let me know if you have any questions. Have a great day.